Hi there, my name is Miss Townsend and I love math. Welcome to Math with Townsend. This video is for data management students studying combinatorics. In this video, we'll look at the fundamental counting principle. The questions come from the FCP practice sheet that was handed out. We're going to start with question 3. It says, using only the digits from the set 0, 1, 2, 3, 4, and digits are not allowed to be repeated, how many 3-digit numbers can be made? So let's think about this question before we start to write down our answer. First of all, we know that we have to make a 3-digit number, that we're only allowed to use the characters 0, 1, 2, 3, and 4, and that we can't repeat. So for example, I can't create a number like 323, because even though it's a 3-digit, and even though it only uses these characters, I violated the rule that says digits cannot repeat. Another one that I could not make would be the number 0, 1, 2, because even though it's 3 digits, even though it only uses these characters and nothing repeats, the problem is when I start with a 0, that's not considered a 3-digit number. It's considered the number 12, which is 2 digits. So that's an added thing to think about. So here's one example of a number that does work, 203. That is a 3-digit number. It's made only of the numbers, from 0, 1, 2, 3, 4, and there's no repetition. Here's another example. So really, this question is saying, if I listed all of the numbers that satisfied the rules of the question, how many numbers in total would we list? So let's look carefully at one of the numbers that we had in as an example. Again, we see a 3-digit number made up only of the digits 0, 1, 2, 3, or 4. And the way we need to do this math, to use the fundamental counting principle, we want to think of each of these 3 digits as being the result of a choice. So when I created this, let me just get my pen working right. When I created this number, I wrote a 2 to start with. But of course, I didn't have to start with a 2. There were some other things I could start it with, like a 1 or a 3 or a 4. So I made a choice when I placed a 2 first. Similarly, I made a choice when I placed the 0 there, and I made another choice. So again, the fundamental counting principle is about the big task to create a 3-digit number. And that big task is made up of smaller tasks. Make the first digit, the second digit, and the third digit. So once we've thought about that, now we're going to actually start to do the math for the question. Don't worry, I'm not going to do that for every question. I just wanted to really lay the groundwork as to how to approach fundamental counting principle. So we have a 3-digit number, and we're going to make our 3-digit number by making 3 choices. The first digit, the second digit, and the third digit. Those are 3 choices. Now we know that we can only use from the set 0, 1, 2, 3, 4, and we've already seen that we don't want to put a 0 there. And we know that we can't repeat. So let's start to make some choices. When I place a number here, I could place a 1, a 2, a 3, or a 4 there. So that means I have 4 choices as to what number to put there. So once I've placed a number in that first position, I'm now going to move to the second digit of the number. How many choices do I have now? Well, I already picked one of these 5 numbers to go in the first position. And I can't pick it again because digits can't repeat. So for example, if I picked the 2, I have 4 choices left. If I instead were to pick the 3, I have 4 choices left. So really, no matter what I picked for that first digit, I'm going to have 4 choices left to fill this middle digit of my number. And now I've filled the first digit and the second digit, and I'm left to fill the third digit. Now how many choices do I have? Well, if I pick a digit for the first position, a digit for the last position, I have 3 choices left. And it doesn't matter which digits I picked. If I pick this digit for the first, this digit for the second, I still have 3 choices left. So no matter what I place in first or second, I have 3 choices for that last position. So in total, to create this 3-digit number, I had to make one decision and I had 4 things to pick. I make another decision where there were 4 things to pick, and then a final decision where there were 3 things to pick. So the fundamental counting principle says we multiply all those choices together. So 4 times 4 times 3 tells me that there are 48 numbers that satisfy the conditions of the question. So let's look at part B. It's the same principle that we're using only the digits from the set 0, 1, 2, 3, 4 Digits are not allowed to be repeated. Now we want to make 3-digit numbers greater than 300. So it's the same question. So let's just say we know that we have 3 choices to make. A 3-digit number has 3 choices to make. Now this time we know that it has to be greater than 300. So that means this first position can only be a 3 or a 4. It can't be a number bigger because there aren't any numbers bigger. And it can't start with a 0 because then it's not a 3-digit number. It can't start with a 1 or a 2 because then it wouldn't be greater than 300. It would be a number like 203 or 142. So we only have 2 choices for that first digit, a 3 or a 4. Now once I place a 3 or a 4 there, here's my set of choices. Once I place one of them there, let's say I place the 3, I've got 4 choices left for that second digit. If I place a 4, I still have 4 choices left. So no matter what, once I've made my decision for the first position, I'm going to have 4 choices left for the next position. Now what about the last digit? Well, I've placed a number here and I've placed a number here. So you can think of it as 2 of them are gone and 3 are left over. And you can see it doesn't matter which 2 are gone. There's going to be 3 left over. So I now have 3 to choose from for that last digit. Oops. So in total, I have 2 choices, then I have 4 choices, then I have 3 choices. So 2 times 4 times 3 is 24. So there are 24 numbers that follow this rule. And here's part C of the question. Now we need to make a 3-digit even number out of these digits, where digits are not allowed to be repeated. So a 3-digit even number. So here's the 3 digits, which represent 3 choices I have to make. So it needs to be a 3-digit even number using only these. So for 3 digits, remember, I cannot have a 0 here. So this is going to be a 1, 2, 3, or 4. In order for it to be an even number, I need to end with a 0, 2, or 4 to make it even. And the middle one is just whatever's left over. So we're going to do the middle decision making last because there's no rules. Now here's the problem with what I've set up. If I start with a 1 in the first position, I have 3 choices over here. End with a 2, a 0, or a 4. But if I start with a 2, I can't reuse the 2 over here, so I only have 2 choices if I start with a 2. So that means if I were to write a 4 here, what do I put here? So if I say I have 4 choices for the first digit, well, do I have 3 choices like I would if it was a 1, or do I have 2 choices? Well, there's no number that means both 2 and 3 at the same time. So because something different happens in my number of choices, depending on if I placed a 1 or a 2, I know I have to use cases. So let's go ahead and look at how we're going to use cases. So the first thing to notice is that if I start with a 1 and I have 0, 2, or 4 to pick from, the same thing happens if I start with a 3. I still have 0, 2, or 4. So case number 1 is going to be if I start with a 1 or a 3 at the beginning. And then if I start with a 2, I can't use the 2 again, so I have 2 choices. If I start with a 4, I'm still allowed to have a 0 or a 2, but not a 4 anymore, which is 2 choices. So I'll have another case where I start with a 2 or a 4. So let's do this question, and I'll use a blank screen here. So again, I'm making a 3-digit number. But let's talk about the specific cases. So in case number 1, we're going to allow ourselves to start with a 1 or a 3. So if I start with a 1 or a 3, that's 2 choices, 1 or 3. Now we're going to talk about this position. That means I can end with a 0, a 2, or a 4. And so whether I start with a 1 or a 3, I have 3 choices for that position. Now the middle number, there were no restrictions on it. I can just pick from whatever's left over. And I've picked 1 character here and 1 character at the end. So I definitely have 3 characters left. No rules for it. So 2 times 3 times 3 is 18. Now case number 2. So let's start fresh and think about case number 2. And in case number 2, we were starting with a 2 or a 4. So a 2 or a 4 means that I have two choices for that first position. Now, if I start with a 2, the end digit can be either a 0 or a 4, which is two choices. If I start with a 4, the end digit can be either 0 or 2, two choices. So no matter which one I pick from, a 2 or a 4, I always end up with two choices for that last digit. So there's going to be two choices to make here. Now the middle digit, again, there were no restrictions on it. So I just say, well, I've put 2 out of the 5, so there's 3 left. So 2 times 2 times 3 is 12. So in case number 1, there were 18 numbers. In case number 2, there were 12 numbers. So the total would be 18 plus 12, which is 30. So there are 30 numbers that follow the rules of the question, which is greater than 300 and even. All right? No, not greater than 300 and even, just even. This is the one that's greater than 300 and even. So let's look at this one. So greater than 300 and even. So again, think about this. I know I'm making a 3-digit number. Greater than 300 means that this is going to be a 3 or a 4. Even means that this has to be a 0, a 2, or a 4. And right away I can see that because I wrote a 4 in both positions, I've got a problem. If I start with a 3, all 3 of these are available to me as choices. But if I start with a 4, I can't put the 4 back in that position, so I would only have two choices. And I can't write both 2 and 3 here, so again, we're going to use cases. So, and what makes sense is we'll start with a 3 as one case and start with a 4. So let's say case number 1, we're going to start with a 3. So if we start with a 3, well, that's one choice. There's one number called 3, so we have to make that choice. And if I start with a 3, I can end with a 0, 2, or 4. So I've got 3 choices to make for that last digit. Now the middle number, there's no restrictions on it. It can be any number left over. I start with 5 characters. So here's the 5 characters I start with. I've used one here, so there's 3 left. So there are 9 numbers in that case. Now case number 2, we're going to start with a 4. So here's my 3 decisions to make. We know we're starting with a 4, so there's only one number called 4. And if I start with a 4, I want to make this even still. So now I've only got 2 choices for that last digit because I can't reuse the 4. Now that I've placed the first and last digit, the middle number, well, there's 3 left over, no restrictions. 1 times 3 times 2 is 6. So there are 9 3-digit even numbers greater than 300 following the rules, and there are 6 3-digit even numbers starting with 4. So the total, the answer to the question is 9 plus 6. There are 15 even numbers greater than 300 that satisfy the rules. So let's look again at a different question. This is question number 4. It says, how many 5-digit numbers exist that are less than 40,000 and odd? So we know that we need to make a 5-digit number. And there's no restrictions here. It didn't give me a set, so I'm going to use any of the characters that we call numbers. So from 0 to 9, there's 10 of them. It has to be less than 40,000, and it has to be odd. And the other thing that's not explicitly written, but you should understand it, is that a 5-digit number can have repeated digits. So for example, the number 44334 is a 5-digit number. Now, it's not less than 40,000, so it wouldn't be one of the ones that I would count, but there's nothing in this question number 4 that says I can't repeat. So I'm allowed to repeat digits if I want. So that makes it a little easier than what we were just looking at. So again, a 5-digit number using these characters, less than 40,000 odd. So the first thing is, if we're making a 5-digit number, I've got 5 decisions to make. So I write these to represent my decisions. So let's talk about the first character. It has to be less than 40,000. So I can't use a 4 or a 5 or a 6 or a 7 or an 8 or a 9. So those numbers, if I start with a 4, I'm more than 40,000. Or I'm 40,000 exactly, and this says less than 40,000. So I know I can't start with a 4 and above. So I can start with a 3, I can start with a 2, I can start with a 1. I can't start with a 0, because if I start with a 0, for example, if I were to count this number, that's not a 5-digit number. That's a 4-digit number with a leading 0, but it's considered a 4-digit number. So that means in the first position, I only have 3 choices, a 1, a 2, or a 3. Again, I can't start with a 0 because it would make a 4-digit number. And if I started with a 4, I'd be more than or equal to 40,000. So the other thing that's a restriction a little bit is that it has to be odd. So odd numbers end with one of these digits. And I'm allowed to repeat, so I don't care that 1 appears here and so does 3, because I'm allowed to repeat. So there are 5 choices for that position. Now in the middle, I have nothing that restricts any choices for the middle. I'm allowed to repeat. So there are 10 choices, 10 choices, and 10 choices. So that's just 15,000. And again, the fact that we were allowed to repeat made this a lot easier than the previous question. So let's look at question 5. How many different numbers with all different digits, so now we can't repeat, are there between 1,000 and 4,600? So we're making numbers again, so we know that we're using this set of digits from 0 to 9. So it's a 4-digit number because these are 4-digit numbers. And if I use less than 4 digits, I'm below 1,000. And if I use more than 4 digits, I'm above this. So I know I'm making a 4-digit number. So I need to use the characters that make up numbers. Repetition's not allowed because it says different digits. And it says I have to be between 1,000 and 4,600. So let's start to think about this number. So a 4-digit number. So 1, 2, 3, 4 decisions to make. So if it's between 1,000 and 4,600, I can put a 1, 2, 3, or 4 in the first position. So I have 4 choices. Now, what about the second position? Can it be anything? Well, no. If I start with a 1, 2, or 3, I can't repeat a 1, 2, or 3, but otherwise I can have, like let's say I start with a 2, I can start with a 0, I can have a 0, a 1, a 3, a 4, a 5, a 6, a 7, an 8, or a 9. No problem if I start with a 2. But what if I start with a 4? So if when I make this decision, I choose a 4, I can't have a 9 in this position because that would give me a number like 4,912, and that's not allowed. It's too big. So in fact, we need to use cases here because starting with a 1, 2, or 3 allows us to use any number except for the repeating number. Whereas starting with a 4, I'm only allowed to go up till 4600. So this is another case where we need cases. So case number 1, we're going to start with a 1, 2, or 3 because starting with a 1, 2, or 3 means that I can use any number in the next place other than the repetition. So 1, 2, or 3, that's 3 choices. Pick one of those and I've got 3 options. This digit, the second digit, can be any number except for whatever I picked here. So instead of 10 choices, I have 9 choices because again, I can't repeat whatever I've just used. This position can be any number except for it can't repeat this one or this one, so there's only 8 left. And this number can be anything except for it can't repeat, can't repeat, can't repeat, so there's 7 left. So again, I picked a number to go first, and I'm only picking from 1, 2, or 3. That's why I have 3 choices. Once I place one of those, I've placed one of these numbers. So I've placed, from my set of original 10 objects, I put one of them here. So let's say I put a 2. So let's say I put a 2, so I can't place it here, so now I've got 9 choices. So now I've made a decision and I put a number here. Let's say I put a 7, whatever. So now I've only got 8 left when I decide what goes here. Let's say I put this one, and now I've got 7 left. And it doesn't matter which ones you actually placed, you're going to have 9 choices, 8 choices, 7 choices after the first 3. So now let's look at the other case. And the other case was where we started with a 4. And again, the reason why it has to be a separate case is because of that second digit. So we know that the first digit's a 4, so that's one choice because there's one number we call 4. Now here, this second digit, I can put a 0, a 1, a 2. I can't put a 3, Oh, yes, I can. I can't put a 4 because that would repeat. I can put a 5, but if I put a 6, well, then I'd have a number like 4, 6, something, something. And I'm only supposed to go up until 4600, and I can't even get 4600 because it repeats the 0. So in fact, I can't put a 6 in the second position because it'll be way too big of a number. Well, it'll be too big. So I've only got 1, 2, 3, 4, 5 choices to make here. So I can have numbers like 4012, 4198, 4267, and so on, but I can't have a number like 4679 because that's too high. So that's why I only have 5 choices as to what can go here. Now, once I've placed those first 2, as long as I know I'm under 4600, I can then pick any number left over, there would be 8, and then any number left over, there would be 7. So in total, if I start multiplying, so in the first case, where I did 3 times 9 times 8 times 7, that's 1,512 different numbers. And in the second case, 1 times 5 times 8 times 7, 1 times 5 times 8 times 7 is 280. So the total for this question is, adding them together, what does that give me? 1792. So remember that you're always thinking about the separate little decisions that make up a number. So a 4-digit number means 4 little choices, and watch for those cases. I hope that was helpful. Remember to keep doing work and asking for help.